Okay, we also need to talk about number types. And this is an interesting thing because the number types that we have mathematically aren't always what we think about, okay? And especially some of the things that we discuss. So things that we discuss and the terminologies that we use. We talk about whole numbers, okay? We talk about fractions and decimals and negatives, right? Those are often all the different kinds of number types that we talk about, okay? And that's the language that we use for our students to understand us. Mathematically, okay, some of those get used and some of them don't. So the smallest group of numbers that we use are called the natural numbers. Now, just so everybody knows, this is not a hashtag, okay? This is actually the number sign, okay? It's also maybe called the pound sign, okay, on your phones and stuff like that. It was originally the number sign, so I can use it in my shorthand. These natural numbers are the ones that we first understand and use in counting, okay? So this is like 1, 2, 3, ... okay? This is called an ellipses, which means that there's more there, but I'm not going to write it, okay? That ... continues this group all the way into infinity. That's a big deal, okay? This is when we first start to understand a concept of unmeasurable amount. So just in this circle, and I said it's our smallest group of numbers, is an infinite amount of numbers. And that's a pretty big deal. This is where we actually teach kids to insult each other on the playground, right? It's like, you suck, infinity, okay? Well, the next thing that they'll often say is, you suck, infinity plus 1, right? So we have the whole numbers. This is the natural numbers. Notice how this is drawn. I'm including all the natural numbers. It's 0, 1, 2, 3, ... okay? 0 is the only inclusion and difference between natural numbers and whole numbers. And that's an important thing. 0 was not actually taught and understood as a value. It was, oh, there's nothing there. And that was it, because we didn't have a huge written language and expectation. And so 0 and say nothing, okay, nothing. But when we started to actually do representations of numbers symbolically, that we do all the time now, 0 came into play. Yeah? So that's an important one. Like, it's not a big deal to us now, but it was at the time. 0 was a huge concept that came into play. Okay? Now, including all of those whole numbers, our next group is called the integers. The integers have all the same numbers, okay, it's inclusive there, but also have all of my negatives in there. So this one starts at negative infinity and goes all the way to negative infinity. So this is the insult, I hate you, infinity plus infinity, right? Double infinity. So this group, in and of itself, is really almost twice as big as this one, okay? I say almost because 0 doesn't have an opposite. 0 is neither positive nor negative. It is the line in between positive and negative. And so how it's represented can be pretty difficult for understanding in positive and negatives. So we have positive numbers, negative numbers, and 0, okay? And that defining line is an important one for us to understand. So here are all of our opposites. So every positive number, everything in the natural numbers has a negative opposite. That's what's included here. And then we still have 0 in there, okay? So this is still like, that's a double infinity, but double infinity is still infinity. This is a bigger infinity than either one of these smaller groups within it. So this is infinity, infinity plus 1, and double infinity. Okay? Now, what comes after that? Then we start to get into what we call rational numbers. Now, rational numbers is the inclusion of fractions and decimals, but not all decimals, okay? This is an inclusion of all fractions because a rational number is a ratio of two integers, a over b, and b is not allowed to equal 0, okay? And that we'll get into a little bit more later, okay? But you'll just say you can't divide by 0, okay? Because depending on how you're teaching division, if you're putting things into groups, right? A, however many there are, and putting those into groups. You can't put into 0 groups. So b can't equal 0, and a and b are integers. Okay? So having that and understanding, every single fraction anywhere that's written as a correct fraction, okay, shows up here. So that means any decimal that can be written as a fraction is in that group. Okay? So all of these things are going to also include the things in between all of our whole numbers, right? So integers, positives and negatives. Now, these are all the little pieces in between. How many numbers are there in between 0 and 1? There's an infinite amount, okay? Just like there's an infinite amount of integers, there's an infinite different ways that I can write all those numbers in between 0 and 1. So this is our infinity times infinity. There's infinity in between each one of my whole numbers all the way along. And so I'm doing infinity times infinity, or infinity squared, okay? If they're, real fancy and they're insulting. Okay? So this is a really interesting setup for it, okay? Now, decimals, which we'll talk a little bit more in that specific number type, don't all show up here, okay? This is all ones that have an ending, a terminating, okay? So like 0.5, that's a terminating decimal. I can write that as a fraction, okay? And then any repeating decimals, okay? Any of those, even if it's 8 digits or whatever, and then it repeats those same 8 digits and repeats the same 8 digits. If it does that, then it falls into this category. But not all decimals do that, okay? So outside of rational numbers, okay, there are irrational numbers. Okay? Now, I'm going to kind of box these in because, and this is a different shape for a specific purpose. Irrational numbers are outside of rational numbers. Okay? The two together create a group called real numbers. Okay? Which we'll come back to in just a second. So these irrational numbers that are a separate group, we have this infinity squared amount of numbers in there. Then we have these irrational numbers. These are those decimals that are non-terminating, non-repeating, okay? Irrational numbers. There are some of them that we know and we're fairly familiar with. One of them in particular is pi, okay? 3.14 is how we round that off, but it actually never ends. If you Google up pi, you'll find like web pages that just keep going forever and ever with the digits of pi, because there's no pattern in those digits that's going to start repeating. Okay? And it never stops. In a true definition of pi, it goes on and on and on. Calculators only have limited memory, and so they'll give you so many digits. Our internet has huge amounts of space on it, and so we can put digits like pi, that's still being calculated. And it's interesting, pi was used to help calculate the speed of things. So they would put a division problem to find pi and see how many digits it would give in a certain amount of time. And that's how we got our processing speed for our computers that we have. So they did it with calculators because they were very small, simple computers. And so a calculator would take a little while and produce an answer, right? As that got faster and faster, said we need to give it a more complex problem. Well, what's more complex than a never-ending, never-repeating number? Okay? Now, other irrational numbers to be aware of and that you may teach if you're, cool enough to teach middle school are things like square roots of non-perfect squares. Okay? Any non-perfect square, when square rooted, creates an irrational number. Okay? And the reason why we call these irrational numbers is the guy who first thought these up, they thought he went crazy and threw him off the boat. He was part of the Pythagoreans, okay, who did the Pythagorean theorem. And that's where irrational numbers actually came from, as far as we can tell. I'm sure that there were other people who had similar ideas, but this is the one that's recorded. Okay, so this poor guy is like, I think that they're square root of 2. I think that number is just like a non-repeating, non-terminating decimal that we'll never even find the end of. And they said, whoa, you're going crazy, and they threw him off the ship. They were on their way to lecture at some great place, I'm sure. Okay, so that's why it's irrational. Yeah? So that defining line, there's infinite irrational numbers out there that anytime that we write a number, we have to represent it like this, because if I start to write the decimal, I've got to do ... and I don't know what that is. Here, there's a consistent pattern that I'm using to find the next term, find the next number. Irrational numbers, this is the best representation of it, is a some other symbol. Okay? So irrational numbers, distinctly different from rational numbers, but rational numbers includes integers. Not every integer is a rational number, but not every rational number is an integer, but every integer is a rational number. Okay? So this is an inclusion, but a specific inclusion. Every natural number is a whole number, is an integer, is a rational, and is a real number, not an irrational number. Okay? Now, like I said, we're mentioning real numbers. All irrational and rational numbers that exist out there are the ones that we use all the time. Okay? If it's not a real number, then it's a complex. Now, a complex number is in the form of a plus bi. Okay? Where a and b are real numbers, I is the representation of the square root of -1. Okay? Which, depending, if you have advanced kids in your middle school, you might have to teach something like this, but I don't usually teach it until Algebra 2, so it's kind of a high school concept. But it's something for you to be aware of, because you're going to get questions from students about, well, what if, because especially when you have to start teaching about square roots of negative numbers, or square roots of numbers, they'll say, well, what about negatives? And that's going to be, well, that's complex numbers. You're going to learn about that in the future. And it's okay to leave some things off like that, because you're not ready to teach that, and they may not be ready to really understand. Okay? So here are all the different number types that exist mathematically. Now you'll get other ones about the specific types that we call fractions and decimals, negatives. Okay, we'll get into each of those a little bit more in other videos.